Hi, welcome to the class. Today we will start a new unit, and the name of the unit is Dual Nature of Matter and Radiation. So earlier we have studied radiation means light. This means light. Earlier we have studied dual nature of light. In this class or in this chapter we will be discussing dual nature of matter as well. But before starting that, we will understand a phenomenon by name photoelectric effect, and this phenomena is explained by the particle nature of light. So this is explained by the particle nature of light. And before this we have studied interference and diffraction, which are explained on the basis of wave nature of light. So photo means what? Photo is something related to photon, and this is related to light. And what type of light? Again, particle nature of light. Now you know that whenever light travels in the form of particle, it travels in the form of small packets of energy, and these packets of energy are known as photons. Packets of energy. And each photon has an energy of E is equals to h nu. Where is h? Where h is Planck's constant and nu is frequency. So this is how it works, right? Now, photoelectric effect is defined as the emission of the electrons from a metal surface when a light strikes with the metal surface. So whenever a light strikes with the metal surface and emission of electron happens through the surface, this is what we call photoelectric emission, photoelectric effect. And when the electron moves, they make something known as photoelectric current, right? So that is the photoelectric effect. Now what happens is, you need a certain frequency of the light. You need a certain frequency of this photon, of this light, right? In order to eject. So there is a minimum amount of frequency which these photons should have, and that is what we call mu naught, and it is what we know as threshold frequency. Now what is threshold frequency? It is the minimum amount of frequency which the photon should have in order to eject the electrons from the surface. So threshold frequency is the minimum amount of frequency which any photon should have in order to eject or emit the electrons from the surface, right? So that is mu naught. So suppose, giving an example, we have a light, a photon of energy nu, of frequency mu, which is less than mu naught. And then we have mu, which is equal to mu naught, and then we have mu greater than mu naught. So can you tell me in which case the emission of electron will take place and in which case the emission of electron will not take place? So you are quite sure that this here emission of electron will not take place because the frequency of the photon or the light is less than something known as threshold frequency. In this case the emission of electron will take place, and in this case the emission of electron will take place. Now the point is, what is the difference between these two? Is there any difference? Answer is yes, there is a difference. What's that difference? So that difference is, in this case the electron will be emitted at the surface and it will not move. The electron will not move at all. It will stay at the surface but it will not move. Here this nu, that is the frequency of the energy, will be divided into two parts. One part is given to the electron to come out of the surface, and that energy, now I started talking about the energy, I am talking about this energy, I am not talking about anymore about this frequency of the light, I am talking about the energy, h nu. It means two parts of h nu will be there. One part will help the electron to come on the surface, and remaining part will become the maximum kinetic energy of this electron. So it means in this case the electron will have a kinetic energy also. Whereas in this case, it will just come out at the surface. Okay, here, other than coming out at the surface, electron will have some kinetic energy as well. Now this nu, h nu, which is energy, will have two parts. One is what we call W, and then remaining will become maximum kinetic energy. Now what is W? W is something which we call work function. Work function. Right? So work function is the minimum amount of energy required to take out the electron out of the surface. So that is what work function is. So work function is the minimum amount of energy to take the electron out of the surface. That is what work function is. And further, if I write, and yes, please keep one thing in mind, that this equation is known as Einstein's photoelectric equation. So this W, the value of this is h nu naught plus half mv square max. This is one more version of this equation, and if I further write it, you can send it that side. It will become h common nu minus mu naught is equals to k max. This is one form of the equation. Right? And I want all of you to remember this, that h is equals to k max upon mu minus mu naught. This we will be using in the next class maybe, and that's why this is important for you all to understand. Now guys, one thing you should understand, that we have studied potential, and potential is work done per unit charge. Now how much charge the electron has? The electron has a charge of E. So work done will be E is the charge of electron. That is 1.6 into 10 to the power minus 90 coulomb. So it will be EV. So what is EV? Work done. Right? W is equals to EV, and work done by the electron. And you know that this work will get stored in the form of kinetic energy in the electron. So I can write this as K is equals to EV. Now what is V? Potential. Now imagine that one electron is coming towards you and you want to stop that electron. How do you stop it? By applying positive potential or negative potential? So answer is by applying a negative potential. So there is, if I make this potential to be negative, the electron will stop. So basically what you are stopping is the kinetic energy of the electron. You are stopping the electron is moving, electron has some kinetic energy, and you are stopping the electron, that is, you are stopping the kinetic energy of the electron by applying a negative potential. And when you do that, that negative potential, this V naught is the negative potential, and it is known as a stopping potential. Stopping potential. So this is the negative potential which you apply in order to stop the motion of the electron. And therefore when I do it, I write K max is equals to EV naught. Why do I write V naught? Because this is the negative potential to stop the electron. So you have to take the total kinetic energy possessed by, or the maximum kinetic energy possessed by the electron. Therefore we write it V naught is equals to K max. I hope this point was clear. And this formula K is equals to EV has come from here. And when you stop the potential by applying the maximum negative potential, that becomes K max is equals to EV naught. I could use this here, and if I use this here, what it will become? H nu minus mu naught. Instead of K max, I can write EV naught, and if I do that, I send it down there and I bring it here. H upon E is equals to V naught upon mu minus mu naught. This is another important equation, and I think we can plot the graphs as well now. Okay. So what I am going to do, using these two equations, this one and this one, I am going to plot a graph, and I am going to tell you what is going to happen if we use this Einstein photoelectric equation and try to do it. I hope you understood about threshold frequency, the work function. These are important things, stopping potential and all this. Now let us plot the graph, and First graph I am going to plot is of kinetic energy and frequency. Is of kinetic energy and frequency. So it is obvious that we have something known as threshold frequency. If our frequency is less than threshold frequency, there will be no emission of electrons. If there is no emission of electrons, hence no kinetic energy, because the first part of the energy or the frequency goes into taking out the electron, that is done. Once the electron is out, the remaining part of the energy, h nu, the remaining part of h nu becomes the kinetic energy. And now since the electron is out here, now the remaining frequency from here to here, that is the remaining frequency. This difference of frequency will become the kinetic energy, that is the maximum kinetic energy. So this is K max. So obviously if this part is K max, this part will be K max. If I try to calculate the slope will be, you all know that slope is equals to tan theta. Tan theta means perpendicular upon base, nu minus mu naught, and you already know that K max upon mu minus mu naught is equals to slope, but you know that K max upon mu minus mu naught is equals to h, and therefore the slope of this graph, what graph? Kinetic energy versus frequency, gives you h, which is Planck's constant. So the slope of this graph gives me h, Planck's constant, right? So this was an important graph. Also the same I can do for this as well. And if I do it here, you all could understand very easily that this is frequency again, and here now instead of kinetic energy I shall do potential V. Again, up till this point nothing will happen. After this, kinetic energy, and this is V naught, new frequency. And you know that this point has to be stopping potential, which is the negative potential. Actually, it should be down there, negative potential. But let us take this way only, as of now, just to understand. And if this is the negative potential, then this has to be negative potential. Again, if you calculate the slope, what will come? Slope is equals to tan theta. And if you do tan theta, then it will be V naught upon mu minus mu naught. If you look here, V naught upon mu minus mu naught, it means the slope of what graph? Potential versus frequency. The slope of potential versus frequency graph gives you h by E. Whereas the slope of K, kinetic energy versus frequency graph gives you h. So these were the graphs which we drew from the Einstein's photoelectric equation. Also we understood about threshold frequency, stopping potential, as well as work function. So these are the important terms and these are the important formulas. These two graphs were important. And next we'll take up these things in the next class. Thank you.